So now, let's talk machine learning and how attackers can craft malicious models, exploit the serialization vulnerabilities, and poison pipeline. And for that, we have Octavian Purcaru, Incident Response Commander at Adobe, and Văşcuță Denis, pen tester and CTFer. Guys?
Hello, everyone. Does this work? Can you decrease the font a little bit? Yeah, perfect. All right. Hello, everyone, and welcome to Trust No Format. I'm Octavian, and together with my friend and colleague, Denis, we are going to explore how something as simple as a model format can become a serious attack surface. So the title of the presentation is literal. So every file format carries with it assumptions, shortcuts, and trust boundaries that attackers love to cross. So if you remember one thing today, make it this. A model file is executable input until proven otherwise. So with that in mind, now raise your hand if you've ever downloaded a model from the internet and just executed it. All right, so this is where our story begins today. That little moment of trust is, I would say, crucial. So I'm Octavian Purcaru, the person you want to have on your side when things go sideways, but you also want to have Denis at that moment. Denis?
Hello, I'm Denis. I'm a former CTF player. I've also got the chance to represent Romania twice at the European Cybersecurity Challenge. I've also got a few cybersecurity certifications under my belt, so if you are new to this field and want to go into certifications, I'm more than welcome to make you some suggestions. That's all from me, and I'll head back to my colleague to present.
All right, so everything we'll share today has the goal to make you rethink the silent trust you put in your ML stack. So now let's get oriented with the agenda. So here is how we'll break this down. First, we'll talk about serialization methods, what they actually do and why they matter. Then we'll walk through the core risks and vulnerabilities in Pickle and GGF, and we'll follow with we'll follow how these vulnerabilities manifest in practice, and finish with actionable remediation tasks. So it's basically a simple structure: understand it, see it, and then defend it. All right, let's start with fundamentals. What are Pickle and GGF and how they differ? So serialization is the process of turning live objects into byte and back again. So we have a couple of methods for this. We'll describe Pickle and GGF. Pickle is Python's native serializer, and it can capture almost anything from tensors to classes, functions. But this flexibility is convenient, but at the same time is also dangerous, because it lets data become code during loading. On the other side, we have GGF, built especially for large language models. It's efficient, binary and metadata rich, but it doesn't execute code like Pickle. So what it does is to store metadata. It stores metadata, and it can influence runtime behavior. So we have two formats and two philosophies. Pickle executes on load, and GGF influences during use. So I'd like to keep this. I'd like you to keep this distinction in mind, because it's going to be the foundation for the risk we're going to discuss later. All right, if you zoom out a little bit, you'll notice that these are on the front page. So Wiz Research exposed malicious AI models in a replicate service. Also, Databricks published an analysis on GGF format vulnerabilities, and also Hacker News ran a story on model payloads that sneak through Hugging Face. So different sources, same message, model files have become a serious infection vector. And the takeaway is quite simple. Protecting AI now means protecting the formats that AI runs on. So with that context, let's break down exactly where the risk hides, starting with Pickle. So Pickle's strength is also its downfall. It can, as I previously mentioned, it can serialize anything. So when unpickled, Python rebuilds objects by calling the functions and the constructors they define. So typical risks here are arbitrary code executing during deserialization. The core principle here being to never deserialize data you didn't generate yourself, and never do it in a privileged environment. But we'll walk through the mitigations later. But for now, remember that Pickle doesn't just store data, it stores behavior. For GGF, this one shifts the threat from load time to runtime, and its danger lies primordially in metadata, and the fields, these are the fields that define how a model interacts with prompts and chat templates. So if your application renders metadata using Jinja, for example, template agent, it's effectively executing attacker control input. So think of it as delayed execution. Pickle attacks happen when you load the file, while GGF attacks happen when you actually use it. And I'll let Denis continue with the first example.
So for the first example, I've chosen a CV in Invoke AI, a known software specializing in generative AI. I've also attached the source code for you guys to see if you can spot the bug. If you couldn't spot the bug already, it's a deserialization bug because the scan file is set to false by default. However, this bug was patched, unfortunately not correctly, as it still was flawed. Because the scan was done from a third-party tool called PickleScan, it introduced new bugs to the loading of malicious Pickle files. A user was able to bypass the scan and gain a RC or remote code execution. As you've previously seen, because the file scan is done using PickleScan, we can use stored save to save our model and execute code. This can be exploited by importing some built-in function from NumPy library that indirectly calls some dangerous functions such like exec to execute Python code as a perimeter, which the attacker can later use to import dangerous libraries inside, like OS library, where we can execute arbitrary OS commands. For our proof of concept, we define our class and the reduce function used by Pickler, which returns either a string or a tuple. We can abuse this with the runString function from NumPy testing private utils to execute the return string, which won't be picked up by PickleScan. For our test, we are also using curl to see if we can get a callback to our server. I've also attached a video for the proof of concept where you can see the full exploitation path. Now let's dive into the analysis part. Here we see the output of dissecting the serialized model using pickletools.this. The key part to focus on is the global and reduce opcodes. The global opcode, NumPy testing private utils, tells the Python Pickle machine to import the function runString from the module NumPy testing private utils. Next, we observe the bin Unicode import OS system, which embeds the actual shell command the attacker wants to execute. Then tuple2 builds the tuple of arguments, the embedded command and an empty dictionary. And reduce actually calls the previous imported runString with those arguments, thus executing the command. With this, we are able to get a callback to our server. For the second scenario, I've chosen to include a significant bug that happened in Llama CPP not that long ago. As you can see, because the chain of vulnerabilities to be exploited can be covered in one screenshot, I'll briefly go over the vulnerability itself. As can be seen, when chat format and chat handler is none, it goes through to the guess chat format method to try and guess the chat format from the metadata. It will then be parsed into Jinja2 chat formatter as parameters to chat handler. Now for where the vulnerability itself lies. The code instantiates a plain Jinja2 environment without a sandbox, then renders attacker control templates. Jinja2 compiles these templates in the call constructor, allowing RCs or denial of service, since Jinja2's renderer evaluates embedded codes like eval, enabling arbitrary code execution. For our proof of concept, we are going to abuse this and see if we can get a reverse shell to our VPS. Onto the exploitation part. Because the GGF chat template is read from model metadata and passed to an unsandboxed Jinja2 environment, attacker-controlled template expressions are evaluated at render time. In this configuration, Jinja2 permits attribute reversal and invocation of callables available via the render context, allowing a crafted template to reach Python objects and execute arbitrary code during prompt construction, basically meaning we can remote code execution. I've also attached the proof of concept for this as well, and in the next slide I'll be delving more into the template payload used. For the analysis part, I'm going to better explain in thorough the functionality of our template. The expression class-based subclasses retrieves a list of all subclasses of the basic object class, and then we check if it's warning by warning in xname. If it is, we access its modules via the module attribute, then access the Python's built-in functions through built-ins. Lastly, we use the import function to import the OS module, which allows us to run arbitrary commands on the machine. Finally, we are now able to create our reverse shell to connect back to our VPS. It uses a FIFO file to pipe our netget command to the bash command to get a callback to our publicly controlled instance. To summarize all our examples, all that can lead to serious supply chain issues. Fortunately, they're happening even on platforms like Hugging Face, as can be seen in the screenshot. Fortunately, they have internal and advanced AV scanning used for uploaded machine learning models when uploading them on the site. However, not all of them contain these protections and tagging for misuse models. Make sure to analyze the models yourself before use, because they might contain backdoors. As you can see in the picture, there are lots of shady models being uploaded to platforms every day. Make sure to either download them from an official source or dive in depth before you decide to use them. Now I'll head back to my colleague to present you the remediation steps for this vulnerability.
All right. Let's close this with the defensive side. So for pickle, I'd say that you should avoid it whenever possible. But if you must use it, restrict the serialization to safe objects and types. And also, as Denis previously mentioned, and it's also on the slides, use waits only true in PyTorch. And always make sure that you run the serialization in a sandbox environment, ideally with no network access and also minimal privileges. For GGF, never render templates from model metadata and treat the metadata purely as data and validate it. Also use, if you can, harden templating runtime if rendering is absolutely required. And disable automatic rendering path in production. And across both, for Pickle and GGF, enforce origin checks and require signatures for every artifact that enters into production. So, final thought, I would say that you need to build systems to fail safely when faced with malicious artifacts. And that was Trust No Format. Thank you. Now for questions, if you guys have questions.
Can we completely stop using Purcaru for this kind of activity?
No, just stop using it for untrusted data. If it comes from inside your organization, then you control the pipeline, Pickle is fine. If it comes from the internet or a user, sandbox it or avoid it.
Thank you.
Hello guys, a really nice presentation. So actually, since you work in the blue team, EDR actually detects these attacks, or?
Well, let me take this one. Well, not natively this stage, but it depends on the signatures you have in the EDR. I would say that EDR tends to catch this at a later stage when the let's call it binary manifests itself, like getting to a C2 or having anomalous behavior, all kinds of that, like the usual executables. Yeah, thank you. Other questions? If not, you can also reach out to us at the Adobe booth. So thank you, everyone.